Investigation of curves, section 3, limiting behaviour. Video 5, cusps, another example. We're going to revisit an example we looked at in the derivative of curves section. So it was the curve with parametric equations, x equals 5 cos t minus cos of 5t, and y is 5 sine t plus sine of 5t, with 0 less than or equal to t is less than 2 pi. Now, we already worked out the derivative of this because we were invited to show where it had a vertical tangent. We're now being invited to show that it has a cusp in the top right quadrant and a cusp on the positive x-axis. Now, when we looked at the derivative for this, we found that interesting things were happening here at the point where t equals pi by 6, and also here at the point where t equals pi by 2. Let's have a look in GeoGebra and see what we can find out about what's happening at these points. So here's the example drawn out for us in GeoGebra, and here are the derivatives that we worked out. So this was x and y, this was dx by dt here and dy by dt, and then dividing one by the other to get dy by dx. So what happens if we substitute into my point of interest t equals pi by 6 and t equals pi by 2? Well, let's substitute this into my expression 5. So I want to know t is pi by 6, and it just gives me a question mark. It doesn't have a definition for the derivative at t equals pi by 6. It can't work it out. And similarly, if I substitute into expression 5, t equals pi by 2, the same thing happens. I get a question. So I'm just going to delete these so that I can tidy things up a bit. Well, let's check first of all that the curve is actually defined at those points. So I want to find the values of x and y when t is pi by 6. So I'm going to substitute into my expression for x, which is expression 1. T equals pi by 6. And I get 3 root 3. And substituting into expression 2 when t is pi by 6, I get 3. So that's telling me that the curve is defined at the point 3 root 3, 3. And also for pi by 2, so substituting for my x, that was expression 1, when t is pi by 2, I get 0. And substituting into my expression for y, expression 2, when t is pi by 2, I get 6. So that's telling me that 3 root 3, 3 is on the curve, that's here, and 0, 6 is on the curve, that's here. So we've shown that the points do exist on the curve. Now we need to show what the derivative is doing as we approach these values. So I want to know the limit from above as t approaches pi by 6 of the derivative, which is expression 5. So expression 5, t pi by 6, and that gives me 1/3 root 3. And now I need to see if that's the same as the limit as I approach from below for my derivative. T is pi by 6. And I get the same. I get 1/3 root 3 again. So that's telling me that this point is in fact just here. Now I want to do the same thing at pi by 2. So I'm just going to edit this to pi by 2 here. And I get infinity. And editing this here, I get minus infinity. So that's telling me that the gradient is approaching vertical from both sides at my point 0, 6. Let's have a look at how to write all of this down. So I worked out the derivative in the previous example. So the derivative dy by dx was cos t plus cos 5t over sine 5t minus sine t. And we checked what happened at the point t equals pi by 6. And we got that x was equal to 3 root 3, y equal to 3. We knew that the derivative wasn't defined at that point, so that's why we're investigating it to see it's a cusp, but it shows that the point is on the curve, so now we look at the limits of the derivative. So first of all, the limit as t approaches pi by 6 from above, and I'm just going to write dy by dx here, I'm not going to write my whole derivative out again. And my computer algebra system told me that that was root 3 over 3. And then the limit as t approaches pi by 6 from below of my derivative dy by dx, my computer algebra system told me that was also root 3 over 3. So that shows me that at pi by 6, the gradient is tending to the same limit from above and from below. So my point 3 root 3, 3 is a cusp. And in the same way, I can consider at pi by 2, I can show that the limit as t tends to pi by 2 from above was infinity, and the limit as t tends to pi by 2 from below was minus infinity. So that was showing me that the point 0, 6 was also a cusp. In this video, you've learned how to use computer algebra system to identify cusps.